Okay, 7.2, we're going to be graphing polar equations. All right, in polar equations, what we're doing is we're using the ordered pair, but not x and y. This time it'll be r and theta. Okay, so everything's in terms of r and theta. So here's our first polar equation, r and theta. And we're going to be solving for r given theta. Now, all the values up here are our theta, so we're just going to plug that into our unit circle and the calculator to get the approximation here. So let's go ahead and grab the unit circle first. We're going to say r is equal to 3 cosine theta. Well, what is theta? First one, cosine, 0. What is cosine of 0? 1. So 1 times 3 would be just 3. Okay, that's an exact value. Okay. Cosine of pi over 6, that's the square root of 3 over 2. So then here what I'll have is 3 times the square root of 3 over 2. So this 3 right here comes from this part, and then cosine of pi over 6, that comes from the unit circle, which is the square root of 3 over 2. Plug that into the calculator and we're going to get an approximation. 3 square root of 3 divided by 2, 2.6. Okay. 3 times cosine of pi over 4. Cosine of pi over 4 is the square root of 2 over 2, so I'm going to do 3 square root of 2 over 2. Plug that into the calculator and we get 2.1. Okay, and we're going to keep going. 3 times 1/2, well, that's just going to be 1.5. Okay, and then let's do cosine of pi over 2 is 0. So 3 times 0 is just 0. Okay, and then let's go over here. Negative pi over 6, which is the same thing as this one. 3 times square root of 3 over 2. Okay, notice that these two are the same value, so I expect this to also be 2.6. Okay, these two would be the same value. So this would be 2.1. These two would be the same value, 1.5. And then, of course, these two are also the same value, which is 0. Okay. Remember, we're looking at cosine, so it doesn't matter. Cosine's an even function. Doesn't matter if it's going positive or negative. Cosine will be the same. All right. Let's go ahead and graph this. So right here is going to be our origin. Let's go ahead and plot our first theta. Theta is going to be 0. 0 is located right here, and we're going out r, which is 3. 1, 2, 3. Here's our first point right here. Okay. Second point is going to be pi over 6. Here's our pi over 6, and we're going out about 2.6. So here's 1, 2, and a little bit more than half, so maybe about right here. Okay. Next point is pi over 4, which is on this line, and we're only going out a little over 2. So I'm going to go 1, 2, and then just a little bit past that. There's my next point. Okay. Next one, pi over 3, which is here, and we're going out 1.5. So here's our 1, here's the half. Okay, notice the shape it's coming along. Now we're going to go pi over 2, which is located here, and that's at 0. So there's my point right on the origin. Okay. Next one is going to be negative pi over 6, which is right here, and that we're going to go out 2.6. So 1, 2, and a little bit more than half. About right here. Okay. Negative pi over 4, that's the same thing as 7 pi over 4, we're going to go out a little over 2. So 1, 2, and a little bit more. Okay. Then we're going to go negative pi over 3, same thing as 5 pi over 3, which is located here, and we're only going to go 1.5. So 1.5 right there. Okay? And then finally negative pi over 2, which is located here, and we're going out 0, which is the exact same point. What did the polar equation look like? Well, I'm going to use my red pen, and I'm just going to connect the dots. The dots actually form a circle. Okay, so this is what our graph will look like. We're going to look at some other examples. All right, so let's look at some of these examples. When we're looking at our circles, we're going to start at the pole, which is our 0, and we're going to go out the number of units of whatever A is. So if A is 3, we're going to go out 1, 2, 3 units. Okay, if A is 5, we go out 5 units. And the center will be at the pole. Okay. When we're looking at this type of equation, okay, I want you to think of this. Think of sine as being positive. If sine is positive, which two quadrants is sine positive? Hopefully you said quadrant 1 and quadrant 2. So the center won't be at the pole, but the pole will be part of the actual circle. So if A is going to be positive, you will be in quadrants 1 and 2. If A is negative, you would be in quadrants 3 and 4. Think of sine as being negative in quadrants 3 and 4. For a cosine value, notice that the center is not at the pole. The pole is part of the actual graph itself. But look at your cosine. Cosine means it's your x value, so x is positive in quadrants 1 and 4. So if A is positive, your circle will go through the pole and be in quadrants 1 and 4. Okay? If A is negative, your circle will be in quadrants 2 and 3, because cosine is negative in quadrants 2 and 3. Okay, we have a few more examples here. These are going to be our linear examples. So when theta is equal to 0, you're going to have a line on the x-axis. If theta is equal to pi over 2, you're going to have a line on your y-axis. Okay, so let's label that. Theta is equal to 0, and here theta is equal to pi over 2. Okay. If theta is equal to any other value besides pi over 2 and 0, it's going to follow that specific line. Notice here, pi over 4, you're going to have a line straight through. So whatever your theta is, your line will always go through the origin and onto the other side. Okay. For a horizontal line that's not on your x-axis, you're going to have an equation that looks similar to this, okay, where y is going to be equal to whatever A is. And for vertical lines, you would have the same thing. Your equation will look similar to this. If this fraction is positive, your r, your vertical line, will be on the right. And then if your r is going to be a negative value, your line would be on the left. Okay? We're going to go over some more examples on our worksheet.